I'm Anil Kumar. In this video, we will learn how to sketch graph of a polynomial from the given equation. Question here is, sketch a possible graph of a polynomial function. A. F of x equals to minus x times x plus 2 times x minus 3. G of x is equals to x plus 5 times x plus 1 whole square times x minus 4 whole cube. You can pause the video, sketch the graph, and then look into my suggestions. Now here, the two examples are excellent examples to understand the whole concept. We'll cover up almost all the techniques required to sketch a polynomial from factored form of an equation. F of x equals to minus, that negative gives us a negative leading coefficient. If I multiply these x's, right, if I multiply these x's, what do I get? I get minus x cubed. Do you see that? So that means we have negative leading coefficient. Is it okay? So that gives us negative leading coefficient. Now what does that mean? On the graph of the function, negative leading coefficient means that right side is down, right? It means when x approaches positive infinity, y approaches negative infinity. We normally will say this as right side is downwards, right? So in short, so it's kind of end behavior which says the graph will be going right side down. So when x is approaching positive infinity, y approaches negative infinity, right? So that is what it means. First thing to understand, okay? Now, second, so we also know it has degree of 3, right? So 3, that means degree equals to 3. That means it is odd degree. Odd degree for us is opposite ends. That is, we are talking about end behavior. If the right side is going down, then the left side will be going upwards. That is what we mean when we say opposite ends, right? So from the leading coefficient, we get the end behavior, and from the degree, we get a part of end behavior, what happens when x approaches the other end, right? So opposite end really means when x approaches negative infinity, y approaches positive infinity. So opposite ends. Do you see that? Negative, positive. This is what I'm trying to say. Okay. So if we know the end behavior from this particular term, right? That is when we multiply these, we get minus x cubed. Now we will analyze the zeros. So when sketching, you have to look into these two parts. The leading term, right? So we have already analyzed the leading term. So we analyze the leading term. Which has a coefficient also and degree. So these are the two things in the leading term which we look into, which define the end behavior, right? So leading term gives you end behavior. Okay, now we will see the zeros. Now zeros we have at the first zero here, x equals to 0 is a 0. So equate each factor to 0. Then we have a 0 at minus 2. So let us say this is minus 2 for us. And then we have a 0 at 3. And let's say this is 3 for us, right? So we have these three zeros. And all zeros are linear. So we have all linear zeros, okay? So that is to say, the graph will cross them, right? So it is not going to be a turning point for a graph, correct? So in linear zeros, the graph is going to cross, correct? So that is how it is going to be. Since we are starting from left to right, going from quadrant 2 to 4, we can actually sketch kind of crossing here. Is it okay? Then crossing at the other end, kind of like this. So that is what we mean when we say we have linear zeros. So we just cross like a straight line, okay? So you have to cross at these zeros. So that is the graph which represents the given condition, okay? So that is how you should be drawing. Now let's follow the same strategy and sketch the next one, okay? So first, let us analyze the leading term, okay? So the leading term for us is, I'm writing all this for you to understand. You don't really have to write when you're describing in your test. So we have x here, right? So x times x squared, okay? And this is x cubed. You don't really have to expand to get the leading term. Just multiply them. So we have x to the power of 3, 4, 5, and 1, 6. So that gives you even degree, right? So it is even degree. That and positive. Even degree means same side. Is it okay? Same side. And we have positive leading coefficient, right? And we have positive leading coefficient. That means right up, right side up, okay? So that is what it means. That means right side is up, both are same side, so that becomes the end behavior. So from the leading term, we got the end behavior. Now here, we will analyze the zeros in greater detail. So let's not try to understand about the zeros. We have variety of zeros in this particular example. So the term x plus 5, right? So the term is, let me write down these terms again to explain the concept. X minus 4 whole cube. So we are multiplying these three terms, correct? Let's write down the zeros. What makes this factor 0? It is minus 5. What makes this factor 0? Minus 1 and plus 4 for this one, correct? Now, in a zero, we always have order or multiplicity, right? So sometimes some books will say multiplicity, and some will refer to that as order. How many zeros? This is linear. Order is 1. We have 2 zeros here, and we have 3 zeros. Now, zeros actually decide behavior. Zeros will decide behavior at x-intercept. That is what it decides. And we'll see how it decides this. So let's begin by plotting these zeros, and then we'll decide. The first one is at minus 5. Let us say this is minus 5 for us, and it is linear. Since we are moving from quadrant 2 to 1, linear means it will just cross it kind of like a straight line. Do you see that? Then we have a 0 at minus 1, which is quadratic, degree 2. So it will bounce back. It will bounce back like a parabola. So that is the second 0 at 2. And then we have a 0 at 4. Now this 0 is cubic, 3 order, right? So it will kind of go like this, tilde. This is the sign, okay, for tilde. So that is how it is going to be. Now we can connect our graph. This is the polynomial. So we'll go straight, right? Then we turn like this, come back to this point. Is that okay? Then go here. See how I'm sketching this. And then go over this graph, and there it goes. So this satisfies the end behavior, right? So we mark the zeros in the beginning. This is minus 5 for us. This one is minus 1 for us, correct? And this one here is 4 for us, correct? So that is how you could sketch the function, okay? This function is g of x. That is x, correct? You could write f of x here. So I hope you understand the technique of sketching polynomials. First, analyze the leading term to get the end behavior, and then analyze the zeros and their order to get the behavior of the graph at the x-intercepts. Once you do that, you can sketch fairly accurate graph. Now let me add one more thing here, and that is you should find the y-intercept. So what we will do now here is analyze and find y-intercept, right? Now y-intercept is also a check. Y-intercept is a point where x value is 0. So in this case, let us calculate the y-intercept. Here g of x, we know what it is, but what is g of 0 equals to? That is the y-intercept. Substitute 0 here, so we get 5 times 1 square times minus 4 cube, correct? So minus 4 cube is negative number, which is minus 64 times 5. So you can use the calculator and say 5 times 64 is 320 with a negative sign, okay? So this point here is minus 320, correct? So that is the the y-intercept. So after sketching, it is a good point to always write 320. I nearly skipped it. Okay. Here it was easy if I write 0 here. So I get f of 0 equals to 0 times anything, we get 0. So the y-intercept is right at the origin, correct? So that is kind of very important. I would have just missed it. Thank God it reminded. Okay, so y-intercept. After sketching, it's a good idea to write down the value of y-intercept in your graph. That actually uniquely defines your graph. Otherwise, you had sketched a family of graph. That is important to understand. I hope it makes sense to you. I'm Anil Kumar. You can always share and subscribe my videos and learn a lot. Thank you and all the best.